Welcome to Brain Vision.
PQ equals to 0.600 meter, RP equals to 0.800 meter. As PQ and RP are perpendicular, so distance QR will be equals to 0.6 square plus 0.8 square and under root. From here it comes out to be 1.00 meter. Okay, so and we have I equals to 5 ampere and 5 ampere and B equals to 3.00 Tesla. Okay, so for the part A, the force on the wire PQ can be written as FPQ will be equals to ILP sin theta, and the angle between PQ and magnetic field is 0 degree, so we can write 5 multiplied by 0.6 multiplied by 3 multiplied by sine 0 degree. Okay, and sine 0 degree is equals to 0, so force on wire PQ will be equals to 0 Newton. This is the force on the wire PQ. Okay, now force on the wire RP will be equals to ILP sin theta, and theta is here 90 degree, so we can write 5 multiplied by L, that is RP. RP is equals to 0.8 multiplied by 3 multiplied by sine 90, and sine 90 is equals to 1. So from here force on wire RP comes out to be 12.0 Newton, and its direction will be into the pace. Okay, so this is the answer for the force on wire RP. Okay, now the force on wire QR FQR will be equals to I, that is 5, L is 1 and B is 3, and theta will be equals to sine theta. This will be equals to sine theta. Okay, and sine theta can be calculated as sine theta will be equals to 0.8 divided by 1, that is 0.8. So after putting this value in this equation, we get FQR equals to 12.0 Newton, and this force will be in the out of the phase. Okay, so this is the answer for the force on wire QR. Okay, now moving to the part B, in which we have to calculate the net force on the triangular loop. So net force will be equals to F, that is FQR minus FRP. As both forces are equal in magnitude, that is 12 Newton minus 12 Newton, so net force comes out to be equals to 0. So this is the answer for the part B of this problem. Okay, so now moving to the part C, now we will calculate the torque. So torque on wire PQ will be 0 as force is equals to 0, and torque on RP will also be equals to 0. Okay, and torque on QR or RQ will be equals to 0.300 multiplied by 12 multiplied by sine 90 degree. Okay, so from here torque on wire QR comes out to be 3.60 Newton meter. So this is the answer for this part C of the problem. Okay, now moving to the part D, in which we have to calculate the torque again, and torque is also given by NIAB sine phi. Okay, so phi is equals to 90 degree here, so putting values, n is number of turns, so 1, and I is 5, and area of the loop is 1/2. Okay, and 1/2 base into height, and base is equals to 0.6 and height is equals to 0.8 multiplied by B is 3 Tesla and sine 90 degree. So from here after solving, tau comes out to be 3.60 Newton meter, which agrees with the part A. Okay, now this is the answer for the part D. Now for the part E, the torque acting on the loop about the axis PR is only due to the force due to QR, which is out of the plane of the loop. So point Q will rotate out of the base, or out of the plane of the figure, okay. This is the answer for the part E of the given problem.